Yesterday we worked with the Pythagorean theorem and we learned how to find the side of a right triangle if we know two of the sides. Today and the next couple days we will be working with right triangles still, but we're going to learn about two special types of right triangles. And we're going to learn about their properties and how we can use those properties to help us find the sides of those right triangles. So today we will start by learning about the special right triangle that's called a 45-45-90 triangle. And so why is it called a 45-45-90? Well, it's going to be kind of obvious once we talk about it, but these are actually the angles of that triangle. So a 45-45-90 will have a 45-degree angle, a 45-degree angle, and then a 90-degree angle. Okay, and so this is actually a special type of right triangle because there are some properties that are very specific to that triangle. Okay, so we're going to learn about those properties and then we're going to learn how to use those to help us solve for different sides of that triangle. So the first thing that I want you to notice about this triangle is the angles actually tell you sometimes about the sides of the triangle. So notice these two angles right here are the same. And so because they're the same, and remember an angle tells you how, how big the sides of the angle open up. So think of it like a mouth. The bigger the angle, the bigger the mouth of the angle will open. And so because these angles are the same, that actually means that these angles, like this angle right here, and that 45-degree angle right there are opening up the same amount. And so because of that, the sides that are opposite of those angles will actually also be the same. So, excuse me, the first property that you have to know about a 45-45-90 is that this side that's opposite of that angle, that 45-degree angle, and the side that's opposite of that 45-degree angle will be the same. And so to show that they're the same, we actually put these little, I call them tick marks, to show that they will actually have the same length. And notice in this triangle, this is a leg of the triangle, and that's the other leg of that right triangle. Okay, so the first property that you need to know about a 45-45-90 triangle, I'm going to put a little bullet point, is that the legs are actually equal. So whatever the length of this leg is will actually equal the other leg of the triangle. Okay, so that's the first property. The other property that is very specific to a 45-45-90 is about the hypotenuse. Okay, and now you could actually do a little work. You can use the Pythagorean theorem to prove this. But the other property that you have to know is about the length of the hypotenuse of your 45-45-90 triangle. Okay, so this is one of your legs, this is the other leg, and they'll actually be the same length. And the hypotenuse, the special thing you have to know about the hypotenuse is in this specific type of triangle, the hypotenuse is actually equal to the length of one of its legs times the square root of 2. So all you really have to know is what is the length of one of the legs. And to get the hypotenuse, you just take whatever that length is, and then you multiply it times the square root of 2. And that will be the length of the hypotenuse. Okay, so those are the special properties that you have to know about a 45-45-90. Okay, so now we're going to practice this with different types of 45-45-90 triangles. Okay, so let's look at some examples here. All right, so the first one, you have to find the length of this side marked with an X and the length of that side marked with a Y. Okay, so the first thing you want to look for is what kind of triangle is it? And notice you have a 45-degree angle, you have a 90-degree angle, and you have an angle that's not marked. If you remember A property or a theorem that we had talked about earlier is all of the angles in a triangle, if you add them up, they actually equal 180. So if you take 45 plus 90 and add them up, you get 135. And if you subtract that from 180, you'll figure out this other angle is actually going to be 45. So you have a 45, 45, 90 triangle. Okay, so if you have to find x and y, well, look at what you're given. You're given this side right here. So figure out, is that a leg or is that a hypotenuse? And notice, because it surrounds that 90-degree angle, this is actually a leg. So looking at your properties, you know that the legs are going to be the same. And then the hypotenuse is actually going to equal the leg times the square root of 2. Okay, so notice x is actually the other leg. So x will actually be the same as the other leg, which is 11. So x will equal 11. And then to find the hypotenuse, so the hypotenuse is the y, we have to take the length of the leg, or one of the legs, and you have to multiply it times the square root of 2. So y will equal one of the legs times the square root of 2. And now for your answers, you're actually going to leave it in simplest radical form. And so notice, if you type this in or try to simplify this anymore, you're going to end up getting a decimal. And so that's actually where you will stop. Okay, so there is the length of the x and the y. Okay, let's do another one. So what if we had a triangle like this? Notice they didn't give you a whole lot of information angle-wise, but they told you that this is a 90-degree angle, and then they told you that these two sides are equal. So if you remember what we talked about earlier, these two sides, if they're equal, that actually means that these two angles have to be equal. So because of that, that'll actually force it to where these two angles will have to be the same. And so the only way that they'll be the same is if they are both 45-degree angles. And the way that I know that is if you take 180 minus the 90, you'll get 90 degrees. That's how many degrees are left over for both of these angles. And so since they have to be the same, you just divide by 2 and you'll get what both of those angles are meant to be. So you have a 45, 45, 90 triangle. So if we have to find x and y, we're going to do the same thing we did before. Okay, look at what you're given. We're given this side, which is a leg because it's surrounding that 90-degree angle. So that's a leg. So think about which other one would also be 10. Well, it'd be the other leg. So which one's the other leg? Well, it's the other one that surrounds that 90-degree angle. So that would be x. So x would also have a length of 10. And then y is the hypotenuse. So just like we did before, to find the hypotenuse, you have to take one of the legs times the square root of 2. So one of the legs has a length of 10, and we just multiply that times the square root of 2, and we have the length of the hypotenuse. So that will not simplify anymore without getting a decimal, and so that's where we stop. Okay, so now those are pretty straightforward. What happens, like if you look, for instance, at number 3, what happens when you're given a piece of information that's not, I guess, as easy looking as the other ones? Well, you still kind of approach it the same way. So look at the triangle. It's a 45, got a 90. And so just like what we talked about over here, that actually means that the other one has to be 45. Okay, and you can do the calculations. Remember, you just add up these two, subtract it from 180, and you'll get that that one's 45. Okay, so now look at what you're given. Okay, we're given this side right here. So think about what that is. Notice it's surrounding that 90-degree angle. And so that means that that is a leg. Okay, so you're given the leg. And so that means that the other leg of that triangle will be the same. So which one's the other leg? Well, it's the other one that surrounds that 90-degree angle. So that would be C. So I know that C would have the exact same length as the other leg. So C would equal 7 square root of 2. Oh, a little ahead of myself there. 7 square root 2. And then to find D, well, look at what D is. It's the hypotenuse. And so remember, and you can write yourself a little mini equation down here. The hypotenuse is equal to the leg times the square root of 2. Well, to find the hypotenuse, which is the D, so I'm going to plug in a D right here, we have to take the leg. So take one of the legs. So one of the legs has a length of 7 square root 2. And we have to multiply it times the square root of 2. So notice you can kind of think of it and plug it in the equation if you want to plug it in that way. Okay. So from there, this one is not quite simplified for us. So we're going to have to review a little bit or talk about a little bit with radicals and how to simplify them. Okay. And so to actually simplify this, notice that 7 is outside of the radical. So since there's essentially, there's nothing in front of this. That means that there's technically a 1 in front of that square root. You multiply the outsides together. So it'd be 7 times 1, which is 7. And then anything that's underneath the radical, you multiply those. So, and you have to leave it under the radical until you can actually take the square root of it. So square root of 2 times the square root of 2, well, 2 times 2 is 4. And you leave it underneath, and then you just simplify from there. So the square root of 4, we know. Square root of 4 is equal to 2. So I'm going to go to the side here. That would be 7 times, well, square root of 4 was 2. And so then all you have to do from there is figure out what is 7 times 2. Well, we get 14. So that would be the length of our hypotenuse. It would be 14. So D has a length of 14 units, whatever our units here are. It could be inches or feet, anything like that. Okay, so let's do another one. Notice, and I think I forgot to mark this one. Yep, I forgot to give you enough information. So let me throw one more piece of information on there. So notice this triangle is also a 45. That would have to be 45, 90 triangle. So all of these lovely properties we talked about applies. All right. So if I'm trying to find the length of A and B, well, I'm going to look at what I'm given. I'm given this side right here. What is that? It's a leg because it surrounds my 90-degree angle. Okay. And so if I have to find A and B, well, let's see. That's a leg. Well, which one's my other leg? It would be the A because it surrounds that 90. And so they would have the same length. So A would also be 8 square root 2. And then B, so let me mark it up here. B is my hypotenuse. And so because that's my hypotenuse, that means to find the length of that, I have to take the leg times, so remember our property here, to find the hypotenuse, you take the leg times the square root of 2 to find the length of the hypotenuse. Well, my hypotenuse is B, so I'm just going to put that letter in there for it. The leg, well, one of the legs has a length of 8 square root 2. You just pick one of the legs. And you have to take the leg times, so I'm just going to bring this down, the square root of 2 to figure out what the hypotenuse is, okay? And so just like what I did before, I'm going to have to simplify this. So I take the outsides times the outsides, so 8 times, well, there'd be a 1 technically out in front of this, so 8 times 1 is 8. And then when I take the square root of 2 times the square root of 2, I get the square root of 4. Okay, and then just like I did before, I'm going to simplify. The square root of 4 is 2, so it'd be 8 times 2, and so that gives me 16. So the length of the hypotenuse in this one would be 16 units. Oh, my paper is moving on. So there we go. All right, so in the next video, we will be talking about how to do problems that are a little bit more difficult just because they give you different information, okay?